This is Understanding Regression Analysis, a Conditional Approach by Peter Westphal and Andrea Arias. Forgive me if I'm pronouncing that wrong. This book is a must-have if you're a data or machine learning scientist or researcher or scientist in any discipline. Like the Matrix, it will help you download the true power of statistics into your mental framework so that you can use it whenever you're approaching modeling in your work. And what we're going to do now is just read a few paragraphs from the preface just to show you how amazing this book is. This book distills years of experience teaching regression analysis to research-oriented students who are not in the field of statistics. For this group, the main barrier to learning regression, and much of statistics for that matter, is the difficulty to model data probabilistically. Once that barrier is cleared, all the rest becomes much more easily understood. The probabilistic point of view in regression is specifically embodied in the model for the variability of y data given particular fixed values of the x data. This variability is modeled using conditional distributions, hence the subtitle, A Conditional Approach. The entire subject of regression is couched in terms of conditional distributions. This point of view unifies diverse methods such as classical regression, ANOVA, Poisson regression, logistic regression, heteroscedastic regression, quantile regression, models for nominal y data, causal models, neural network regression, and tree regression. All are conveniently viewed in terms of models for the conditional distributions of y given particular values of x. Unlike regression models, for example, linear models presented in other books, conditional distributions are the correct models for regression data. They tell you that for a given value of your x variable, there is a distribution of potentially observable y values. If you happen to know this distribution, then you know everything that you can possibly know about your response variable y as it relates to your given value of your predictor x. The model explains 100% of the potentially observable y data. Unlike typical regression approaches based on the R-squared statistic, which explain only a fraction of the y data, and are also incorrect in that assumptions are nearly always violated. Consistent with the conditional distribution framework, which describes models for the real processes that produce the data, regression models are likewise presented as producers of data, rather than entities that are produced by data. This simple probabilistic view can be difficult at first for students who have come to understand statistical models, regression models in particular, as entities that are produced by data. Once this hurdle is cleared, however, all of the notoriously difficult concepts of statistics become understandable. For one example, to understand standard errors in regression, one must first understand the idea of potentially observable data sets, which is easy to understand when regression models are viewed as producers of potentially observable data. This book is a must-have. It's incredibly well written. It's great for everyone, whether you're a statistician already or if you don't understand statistics and you're doing modeling, if you're a data scientist, if you're a scientist, if you're a biologist, if you're working in the lab and you don't understand statistics, or you do have some familiarity with statistics and you want to increase your understanding. This book is really, it's just unbelievable. Here it is again. Check it out.